Hello, welcome to Recitation 5. Today we're going to be demonstrating the basic probability rules with addition, general addition, complement, and independence through simple problems. So task 1. 2 men, M1 and M2, and 3 women, W1, W2, and W3, are in a chess tournament. Those of the same sex have equal probabilities of winning, but each man is twice as likely to win as any woman. Find the probability that a woman wins the tournament. So here we want to find a probability that a woman wins the tournament. So this means that the probability that woman 1 wins, or woman 2 wins, or woman 3 wins. And since we have or, this is going to be addition. So this is let PW1 denote the probability that woman 1 wins, and PW2 denote the probability W2 wins. So we're going to add up these 3 probabilities that probability woman 1 wins, plus the probability woman 2 wins, plus the probability that woman 3 wins. And how do we find what like PW1 equals? So, sorry about that. So here I have, let PM denote the probability that a man wins. So we were given that that those of the same sex have equal probabilities of winning, but each man is twice as likely to win as any woman. So that would mean that PM equals 2 times PW. So in other words, the probability of a man winning equals 2 times the probability of a woman winning. And so the probability of someone winning is equivalent to PM plus PM, because we have 2 men, and then 3 women, so plus PW plus PW plus PW. And here we know that PM equals 2 times PW, so we can substitute PM for 2 times PW. And then if we add up all of the PWs together, that equals 7 times PW, or there's 7 PWs. So the probability that someone wins equals 1, because someone must win. So we can set 1 equal to 7 PW, and to solve for PW, that equals 1 over 7. So to go back down here, we can PW1 equals 1 over 7, PW2 equals 1 over 7, and PW3 equals 1 over 7. So we can add those together and we get 3 over 7. All right, part 2. So going back, if M1 and W1, so the first man and the first woman, are married, find the probability that one of them wins the tournament. So we want to find the probability that M1 or W1 wins. So here we have a or, so we're going to be adding these probabilities. So that's PM1 plus PW1. And so we know from earlier that PM1 would equal 2 PW1. So if we make that substitution for PM1 here, we would get 2 times the probability that woman 1 wins plus the probability woman 1 wins. So that would be 3 times PW, or PW1. And as we discussed earlier, the probability of woman 1 winning is 1 over 7. So we would have 3 times 1 over 7, which is 3 over 7. So for both part 1 and part 2 of task 2, the answer is 3 over 7. Okay, task 2. Real estate ad suggests that 54% of homes for sale have garages, 31% have swimming pools, and 22% have both features. use a Venn diagram to answer parts A, B, and C. So the first question is, what is the probability that a home for sale has a pool or a garage? So first I'm going to start with the Venn diagram. So we're given that garages, or real estate ad suggests that 54% of homes for sale have garages and 31% have swimming pools. And then 22% have both features. So the intersection of this Venn diagram is going to be 0.22 if I zoom in, and then we have 0.54 for garages and 0.31 for swimming pools. So we first want to know the probability that a home for sale has a pool or a garage. So here we have the probability of a pool or the probability of having a pool or garage equals the probability of a pool plus the probability of a garage minus the intersection of having a pool and a garage. So here we're given that the probability of having a swimming pool is 0.31. The probability of having a garage is 0.54. And then the intersection we were given of having a pool and garage is 0.22. So if you do 0.31 plus 0.54 minus 0.22, you'll get 0.63. All right, so what is the probability that a home for sale has neither a pool nor a garage? So here we're interested in the shaded region. So if it has neither a pool nor a garage, then that means we're interested in real estate that's outside of this Venn diagram. So this is going to use the complement rule where we have the complement of neither a pool nor a garage is having a pool or a garage. So we can do 1 minus the complement, which is having a pool or a garage. And we just found in part A that having the probability of a pool or a garage is 0.63. So we would do 1 minus 0.63, and that gives us 0.37. All right, part C. So the question stem is, what is the probability that a home for sale has a pool but no garage? So the probability of having a pool but no garage is equal to the probability of having a pool minus the intersection of the pool and the garage. So we're interested, in other words, in the shaded area. So we need the probability of just having a pool and then of having a pool, and then we're going to subtract that intersection. That way it's not double counted. So we have the probability of having a pool is 0.31, and then we're going to subtract the intersection, which is 0.22. So that gives us 0.09. All right. Task 3. You roll a fair die 2 times. What is the probability that you roll all 6s? Okay, so first, let's talk about what is the probability of rolling a 6 on 1 die. Well, since it's a fair-sided die, since it's a fair die, there's only one side of that die that has a 6 on it, and there's a total of 6 sides because it's a cube, or you can think of that you can roll a 1 through 6. So the chances of rolling 1 6 when you roll 1 die is 1 over 6. And then the probability of rolling 2 6s, well, we're going to have the probability of rolling a 6 times the probability of rolling a 6 again. So 1 over 6 times 1 over 6 is 1 over 36, and that gives us the answer of 0.02778. Okay, what is the probability that you roll all odd numbers? So the probability of rolling an odd number, well, there's 3 sides of the die, or 3 numbers that are odd, right? We have 1, 3, and 5 are odd numbers on a die. So there's 3 out of the 6 total sides of a die that would make you roll an odd number. So if you simplify or so 3 6 equals 1/2, and then but we're rolling this die twice, right? So we need to know what the probability of rolling an odd number 2 times is. So we would take the probability of rolling an odd number times the probability of rolling another odd number, which is 1/4, or 0.25. All right, what is the probability that none of your rolls get a number divisible by 3? So here, let's see, the probability of rolling one die with a number not divisible by 3. So how many numbers on the die are not divisible by 3? So here we have 1, 2, 3, 4, 5, 6, but out of these numbers, 1, 2, 4, and 5 are not divisible by 3. 3 is divisible by 3 because 3 divided by 3 is 1, and 6 is divisible by 3 because 6 divided by 3 is 2. So here, the probability of rolling one die with a number not divisible by 3 is 4 over 6, which can be simplified to 2/3. But now we're rolling 2 die, so what's the probability of rolling 2 non-multiples of 3? So we would take 2/3. That would be the first die, and then the second die is of rolling a number that's not divisible by 3 is also 2/3. So that would give you 4/9 or 0.44 repeating. What is the probability that you roll at least 1 5? So here we can use the complement rule, where the complement of rolling at least 1 5 would be not rolling a 5 either roll. So you can do the probability of rolling at least 1 5 equals 1 minus its complement, which is the probability of not rolling a 5 either roll. So here, if we were to break down what is the probability of not rolling a 5 either roll, so that means you could roll a 1, 2, 3, 4, or a 6. So that's 5 different sides that it could land on out of a total of 6 sides on a die. And since we're rolling this die twice, you would multiply 5/6 by 5/6, because this represents rolling it the first time, and then this represents rolling it the second time. So we would do 1 minus this quantity here. So this quantity here is 25/36. So 1 minus 25/36, well, if I'm doing this by hand, 36, you want this common denominator, so 1 is equivalent to 36/36, and then minus 25/36, you get 11/36. And so, which is equivalent to 0.30556, which matches our answer. All right, what about if you, what's the probability that the numbers you roll are not all 5s? So here, I'm using the complement rule again. So the probability of rolling not all 5s is equivalent to 1 minus its complement, which is the probability of rolling all 5s. So if we roll all 5s, that means the first roll, there's only one possibility of getting a 5 out of the 6 sides. So that would be 1/6. And then here, the second roll is also, we would roll a 5, which would be, there's only one side out of that die that has a 5. So that would be 1/6 again. So 1 minus this quantity here is 1 minus 1/36 And then, once you simplify all of that and do the math, that's 35 over 36, or 0.9722 repeating. And thank you. That concludes recitation 5. I hope this helped.